Let's talk about file, input, and output. Specifically, in this video, I'm going to talk about file output. I'm going to code up a simple, short example of how to write a string to a file. And we can write multiple strings to the file. But there's a lot of important concepts in this video. Namely, when you're programming in C, you're getting familiar with it, you need to dive into the documentation and see how to use or study how to use these functions, okay? And more importantly, find out what exactly is provided in these standard library header files, right? And that'll tell you what type of functionality that you have at your fingertips to program, right? Generally speaking, if you're trying to do something, it's done for you, for the most part, in the standard library. Not everything, obviously, right? But a lot of stuff is. So let's go ahead and get into it. So I'm going to start by creating a main.c file. Okay, so, and then I'll add a header up here just to say demonstrate file I/O, like that. And then the next thing we do is we need to include the standard IO, stdio.h. Now, you know, in this bootcamp, we've pretty much been including standard IO.h and then using console functions to write and read text from the console, okay? But we haven't really dived into the standard IO.h. So let me just flesh out the main function here. Main and open brace, closing brace, and then return 0 space 0. Save that, and let me pull over some documentation here. This documentation comes from the open group, so opengroup.org, specifically pubs.opengroup.org. Okay, so I'm just going to look at the standard IO header. So we're going to need a file. The file is a structure containing information about a file. So to write to a file, you need to create a pointer to a file. And we're just doing very simple string output. We're going to write strings to a file with different modes. Okay, 2 to be exact, and I'll talk about those in a second. However, in order to write to a file, you need to open it, and there's a function called fopen. So we're going to come down here, and we're looking, because there's a section here, the following shall be declared as functions, right, and may also be declared as macros. So this is a list of the functions that are in the standard IO.h header file, okay? So I'm looking for fopen, and here it is. So you see that when you call the fopen function, it returns a pointer to a file structure and takes 2 arguments. But when you're looking at this, and this is the hardest part when you're learning how to program in C, you see const char asterisk restrict, and you ask yourself literally, like, WTF? Like, what does that mean, right? So what you need to do is you need to scroll down further and look for a link to the documentation on each of those files. Okay, so for example, you scroll down and it says see also, and there'll be a list. So there's the fopen, so I'm going to open that in a new tab. Okay, and I already have one open here, so I'll just go there. So there's the fopen documentation. So it says, you know, synopsis, it's in the standard IO.h. Well, we know that because we were looking at that. And here's a more complete kind of like not example, but, you know, how to, you know, the definition of the declaration of the function, I'm trying to say. So it returns a file pointer. Okay, we know that. And then it takes a path name argument, and it takes a mode. So the path name will be the name of the file. It could be the complete absolute path, right? So And be careful, like if you're programming C on Windows, then you have to formulate the path correctly, because you got backslashes on Windows and forward slashes on Linux and Mac OS. But the path name, if you just have the name of the file, and I'll show you this in a minute, then it assumes that you're just in the working directory. And literally, this is what most of the examples, and this will be no different for the simple example, on YouTube show, right? Like you create a file, give it a file name, and then wherever you run that program in that same working directory, that's where that file is going to be created. But you could put the whole path. You could say, C:\/ or tilde / which means, your home directory in Linux and Unix, tilde / users / tilde / temp or whatever, right? So you could put the entire path or relative path, right, if you wanted to. And then the mode. So what are these modes? So you scroll down a little bit more and it talks about these modes. So when you open a file, you can open it for reading, for writing, for appending, okay, and then a combination. So if you open a file for reading, then the file has to exist, right? If the file doesn't exist, and how do you know that, right? Because you come down here and it'll say like what these modes, what are the effects of these, okay? You also see a mode called RB, but you can discount the B because the character B shall have no effect. It says right here. Open a file with the read mode R as the first character shall fail if the file does not exist or cannot be read. So this is why it's important to dive into the documentation. You need to know what the side effects of these are, okay, and then program accordingly. So if you use a plus sign, then that means you can simultaneously do operations, read and write operations on the file. Otherwise, if you don't open it with the plus, then you can only do the reads, you can only do the writes or the appends. And so we will probably take a look at that too, maybe in another video. But simply, I'm going to demonstrate W for writing and show you what the effects are, and then appending A. So we're going to use these two file modes, W and A. All right, and so we need a file. And then once we open a file, how do we actually write to it? Okay, so just like writing strings to a console with the put char or printf or put s, there are I want to say synonymous functions that work with files, and they start with an F, right? So if we come up here, we'll see fprintf, right? I'm not going to use that one in this example, but I'm going to use fputs, okay? And then it returns an integer. So you're like, if you're not absolutely burning with curiosity what that integer means when you call this file, you should be, right, as a C programmer. So then you got to come down to the list of functions and look for fputs and open it, right? I want to open that in a new tab, and we take a look, right? So there's how we do it. So the first argument is a pointer to a string, right, of the string that we're going to write to the file, and then a pointer to the file itself, which they call stream in this case, right? So we'll see this in a second. And then you have to scroll down to the return value section of the documentation, and it will say, upon successful completion, fputs shall return a non-negative number. So if everything goes well, it'll be greater than 0, right? Or 0 and above, non-negative, right? Otherwise, it shall return EOF, which is end of file, and that's a constant defined in stdio.h, and set an error indicator for the stream, okay? So, chances are, well, you know what? Look, anytime you do file I/O, disaster can strike, right? Like you're out of disk space, you've got the wrong path, it's restricted, you can't write to it, so you never know what the outcome's going to be, right? But that's what this return value is for, okay? Is to figure out whether or not your write was successful or not. So now that we are armed with a little bit more knowledge about the functions that we're going to use, let's go ahead and code, right? So you have to do this too every time. Until you get familiar, right? You get to a point in your programming that you don't need that anymore. So let's go ahead and declare a file. Now I'm going to use, so there's the constant, right? Again, that comes from stdio.h pointer, and I'm going to call it fp for file pointer. You can call it literally anything you want, right? You see a lot of examples with fp, and like for example, if you had multiple files that you were opening and this was your data file, you could call it data file, right? You're just going to have to refer to it as data file, throughout your program. I'll just go back to fp just to say, hey, this is a pointer to a file pointer. And what I like to do is set it to null, right? Because you could also call fopen right away, okay? Like you could combine the declaration and the definition for that fp pointer in one line. But usually you're not just doing everything in a main function. You usually have multiple functions, and so sometimes the definition or the declaration of your file pointers are separate from when you actually create the file. But in this case, I'm going to say fp. Now I'm going to open a file, fp, okay, equals fopen. Okay, so then we look at what Visual Studio is telling us here. So we need a const char for a file name and a const char for the mode. So I'm just going to say test. I'm going to say output.txt and then comma and then the mode. So the first mode we're going to use is W. So now if I'm going to say if I want to test to see if this is actually going to work, right? So I'll say if, if fp, okay, in other words, if if file open actually returns something, okay, and that's not null, then I'm going to do a write. So now we're going to say, I'm going to say result, int result equals, and then fput s. Okay. Now it takes a string that you're going to write. So I'm just going to say this. Oh, let's just do traditional, right? Hello world. Oops. Hello world. Right. That's what everybody writes on their first program. Writing something to a C or a file should be no different, right? And now we need a file, fp. All right. So semicolon. Now let's go ahead and print the results of writing the file. So I'm just going to say printf. Okay. And then I'm going to use a conversion. Hang on, a string, right? So percent d, and then before I do that, I'm going to say results of, I'm just going to say results, right? Result equals percent d, and then comma result, like that. All right, so we're going to run this. It's going to run once, right? And whenever we execute the program. So let's go ahead and compile first to see if everything works fine. So I'm going to go to my iTerm, clear the screen, do a dir just to check, right? So there's my main C. So gcc-o main.o main.c, right? So run that. Okay, so far so good. And then now run it. Main. All right, so result 12. So I'm thinking 12 in this case, right? I don't think the documentation said anything. It returns a non-negative number upon completion. But I think what this is the number of bytes that were written, because hello world just happens to have 12 characters in it, right? So we can test that theory here in a second, which is kind of nice to know, right? So we could also change result to say number of chars written. However, so let's go ahead now and take a look at, what exactly was written. So now if we do a dir here, like I'm in Linux, I'm in my Mac OS, right? So when I do a dir, I have a alias in my bash_profile. You would need to do ls-al to get the same results, right? So you see output.txt. Now let's just do a cat output.txt, and we see hello world. Now because we used, let's talk a bit about the file modes. Because we opened this file with a W file mode, okay, that's every time we run this program, it's just going to overwrite that file. Let's run it one more time. So let's go back to iTerm, and let's just run that file one more time, or run that program. And now we do a dir. It says 12, right? So it wrote hello world again. And if we cat output.txt, we see it just has one hello world string in there. Let's change the file mode to append A. Hit save. Now when we run this repeatedly, what we might want to do though is we're putting S, right? We're not using a line return. So let's just see what happens when we do that. So I'm going to run this. I got to compile it again, right? I made a change. And then run it. So 12, now cat output. So hello world, hello world. Okay, so it just, keeps on appending it. It's a string, right? The only way, if you wanted carriage returns in there to show up when you catted it, right, you'd have to put the /n. So let's go ahead and do that. If that's our intention, right? If we want this to be a line like that, save. Then we're going to have to recompile. All right, let me get back to my terminal. I saved it. Recompile. Run it again, and then cat the output. And okay, so you're not going to be able to tell, right? Because these two were written, and that these two didn't have any carriage return line feed, but this one does, right? So let's run it again, and we should see another hello world on the next line. So run it one more time. No need to recompile. And now cat output, and we've got hello world on this line here. Okay, so essentially that is how you write a string. Now the string, I've just hard coded it into here, right? So we could totally do something like this. String, I'm going to say a char, right? Actually, I'm just going to say string. I'm going to say message equals, I'm just going to create an array, right? And say, hello world, like that. And then /n. Save. And then here, I'm just going to pass in the name of the array. So message, like that. Okay, so now let's go ahead and recompile this. What did I forget to do? Oh, you know what? My Python programmer is kicking in. Let's go back to the code and let's put the semicolon. You guys probably saw that and were screaming at me like, you idiot, put the semicolon on there. All right, so let's compile it one more time. And clear the screen and run it. And now we've got 13. And the reason why is whenever, well, because I'm writing that carries return line feed, right? So let's do cat output text. And of course we have another one. So same effect, right? Whenever you see a char pointer, you can pass in an array name, right? Like this right here. You can anything. You can pass in the string directly. But in another example, let's do this, right? So we already know that we can put, you already know at this point how to create separate functions, right? So let's say that we wanted to create this and just write any type of message that we wanted to. So what we would do is come up here with and create a function definition. Let's just say void. Let's just say int, right? Say int, because it'll return characters written. We could do that, right? So let's, as a programmer, it's your imagination, right? So I'm going to say save message. Save message, right? To file. And this function is going to take, let's just have it take a pointer, char pointer, and say message, comma, and file pointer. We'll do it this way to kind of make it a little bit easier, right? But still, we're passing in file. Okay, we'll call it stream. Like the documentation does, semicolon. So now there's our function prototype. I'm going to put this up here and just say function prototype. And then below the main function, I'm going to say int save message to file. All right. And then char pointer message file pointer stream open brace close brace. Okay, so what we're going to do is we're going to get an incoming stream, and we're just going to call, so it's already going to be open, right? So essentially this stuff is going to be done for us, and I'm just going to replace this, right? And put that down here. V. So let me just get rid of that. Now we might have to rework this just a bit, right? So if stream, here I'm going to call it stream, right? So if stream, then actually what I'm going to do is say, I'm going to declare this int result equals 0 outside because I need to be able to return it. All right. So we've got int result equals 0. If stream, right? Then fputs message stream. Okay. And print result. Actually, I'm going to get rid of the print, and we could print that if we wanted to. I'm just going to say return result. Like that. And we'll let the calling program figure out if it wants to deal with the result. Okay. So stream, stream, stream. Okay. Message stream. So now let's go ahead and replace what we took out here in the main function. And we could say print, right? Print F $D, right? But I'm going to say result equals, I'm going to say characters written because that's exactly characters written to file, and then comma, and now save to message. So anywhere that an int can be used, a function that returns an int can be used, right? So save message to file, and then I'm going to say I've got this message, right? Message and FP, just like that, semicolon. Alrighty. Now let's compile this. You know, cross your fingers, right? That's every software engineer's mantra. Okay, it compiled. So now let's run it. Actually, yeah. So you know what I'm going to do? I'm going to start off with cat output. I'm going to just remove rm output.txt. So now dir. So now let's run this /main.o. All right, so characters written to file 13. Let's do a dir. We see the output text and cat the output text. So the cool thing now is, right, we have this function that allows us to pretty much, you know, we always could have done it. We just write different messages, right? We could say characters written to file. I'm just going to copy this because I'm going to call this repeatedly. V, I'll do it again. V. So 4 times. And so instead of the same message, right, I'm just going to feed in different strings here. So we're appending. So now the appending, the A mode for file behaves like this, right? If you write something to a file with the append mode and the file does not exist, it will create it. Just like write, except for every time you call something to write to that file, if it's in the append mode, then it will add it to the end of the, go to the end of file and add it there, right? So I can say boy, I'm going to say, oh, I love C programming. You know, I know this video is probably approaching the maximum attention span of, you know, a lot of my listeners, right? So I'm almost done. Let me just come up with a few more witty repartees here. March. Ooh, March is going out like a lion. And for the last message, I'm going to say, I hope you enjoyed this video. Double exclamation point. Save. Now I'm going to have to compile this, right? Because I've added those direct strings. So let's go back to iTerm and let's compile it again. And let's run it again. Right? So it's all on one line because I didn't put this. Come on, there we go. Slash n, right? I should put /n at the end of each one of these. So no harm, no foul, right? Lesson learned. /n. This is what programming is all about. /n. So now if I run this again, I'm just going to get double those messages in there, but that's okay. I don't care. Let's compile it and run it again. Oops. And run it. Okie dokie. So now let's cat the output, and we should have a boatload of messages, right? Oh, I didn't put, I'm not putting carriage return live feeds in these either. Well, you get the point, right? So how to write stuff to a file. Now in the next video, I'm going to show you how to read a file. So maybe we can read all the lines, right? So if we put lines in here, then we should be able to read the lines in the file a line at a time, or read the entire file. Okay. Let's go ahead and rerun this. Compile it and run it one more time. And then, But this is fun. You know what? When you first learn how to program, it's like it's a voyage of discovery, right? So cat output. So if you enjoy this type of stuff, I do, right? Which is why I'm a software engineer. I like learning new languages and figuring out how things work. Okay. But this is kind of the way I want it. Each one of those calls to the save message to file will take the message that you pass to it and save it to file. Alrighty, so you could modify this program, okay, and we'll do it. I'll do this in another video where you want to, like as an exercise, write a program, right, that prompts the user for a line of text and then saves the line of text into a file every time the user hits return. Okay, so that will be one of the examples that I will actually walk through. But to do that example, you need to know how to write to a file. So just a quick review. You need to understand the contents of stdio header, which is one of the libraries with C. You're going to use the file structure. You're going to create a pointer to the file structure. I set it to null initially, and eventually you're going to open, right, the file. This is just an array with a standard message, hello world. All right, and then you're going to call fopen, which is a function in stdio.h that takes the name of a file, right, text name of the file, and if it's not a path, right, then it will open it up in the working directory, and the working directory is the directory where you execute the program that you're working on, right? So that's why output text shows up in the same folder as main.c and main.o, right? The file mode, we use W for write, and every time you use W, it will recreate the file and write over everything. If you use the append or the A file mode, it will append all the messages. If the file does not exist, it will create it. But once it's created, it will just add those messages to the end of the file. If you want to write a line for each string that you write to the file on a separate line, then you need to add /n. Okay? That's it. I will see you in the next video where I show you how to read text from a file. I hope you enjoyed this video. Not so fast. One very important thing that I need to mention is whenever you open a file for I/O, you need to close that file when you're done with it, right? So I'm going to take care of that by coming down here to line 19 and adding a few lines and tabbing over. And I'm going to say fclose. There's a function for that too. All right, and it takes the name of the file, right? So in this case, it's fp. So we need to make sure that you close that file. I also too like to return the pointer, so fp equals null, right? Just like that. Okay. So we open the file. We perform some file I/O with it with the save message to file. And then when we're finished, we clean up our resources. You always want to make sure that you are closing this file, right? So I apologize for leaving this out. Close file. Always. Right? Don't forget. That's enough to emphasize. Don't forget, close the file. As with any type of memory or resources that you allocate when you run your program, you want to, if you open a file, close the file. If you allocate memory, deallocate memory. Okay? And essentially, that's what this is doing, right? Because this is a pointer to a file. So somewhere in this fopen, it is returning. It's opening up, allocating memory for a file pointer, opening up that resource, and returning a pointer to that file handle. So you always want to make sure you close that file. All right, and now let's go ahead and recompile this one more time, just to make sure that we haven't that everything still works, right? So come here, just come up, recompile it, and then run it. Everything should run fine, and it does. And then cat the output text, and there we go. We got plenty of strings in there. So yeah, I would just want to make sure I ended this on that note, right? Just make sure you close your resources. Thank you again. I hope you enjoyed this video, and I look forward to seeing you in the next one.